Let us see a very interesting question from the chapter Mathematical Induction. Here question is, prove the following by the principle of induction for all n belonging to capital N. You know capital N is set of natural numbers. Here statement is 1 by 2 plus 1 by 4 plus 1 by 8 plus up to 1 by 2 to the power n is equal to 1 minus 1 by 2 to the power n. This mathematical statement is given, and mathematical statement is generally denoted by this notation Pn. Okay, so this is the Pn, this is the mathematical statement which is given here. So let us see the solution now. Solution is very simple. We have to take 3 steps only for solving this question. First step, we have to prove that P1 is true. Means when we will put n is equal to 1, we have to show that this statement is true. Second step, we assume that PR is true. Means when you put n is equal to r in the given statement, then you will get PR. So we assume that PR is true. And the third and the last step, you have to show that PR plus 1 is true. These are the only 3 steps, and by doing all these 3 steps, we have to write a single statement, single line, that by the principle of mathematical induction, this given statement is true for all n. Okay, so let us start the solution here. Here given statement is 1 by 2 plus 1 by 4 plus 1 by 8 up to 1 by 2 to the power n. This is equal to 1 minus 1 by 2 to the power n. Let us call it relation number 1. This is first, and this is given statement. Okay, now first step, we have to show that P1 is true. That is, whenever we will put n is equal to 1, we will get P1, and that will be true. We have to show it. So put n is equal to 1 in relation number 1. We are getting here n is equal to 1 means we are taking only one term here. So one term means first term is 1 by 2 in left hand side, and right hand side will be 1 minus 1 by 2 to the power 1, putting n is equal to 1 here. So we are getting here half, and in right hand side 1 minus 1 by 2 is half. So we are getting here LHS is equal to RHS. It means therefore P1 is true. Now second step, we have to assume that PR is true. That is, whenever put n is equal to r in the given statement, this will be established, this will be true. So that is 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 2 to the power r, putting n is equal to r here, is equal to 1 minus 1 by 2 to the power r. Let us call it relation number 2. So we have assumed it. And third and last step, we have to show that PR plus 1 is true. PR plus 1 is true. That is, we have to show that, let us put n is equal to r plus 1 in relation number 1. So here LHS will be 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 2 to the power r plus 1 by 2 to the power r plus 1. And right hand side will be 1 minus 1 by 2 to the power r plus 1. So we have to show here that this statement is true, this relation is true. Okay, this expression is true. We have to show here. So we'll start here with left hand side. So therefore left hand side is here 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 2 to the power r plus 1 by 2 to the power r plus 1. By solving this expression, we have to come to right hand side. Then we will be able to show that LHS is equal to RHS. Okay, so this is left hand side, but you see here this relation number 2 up to this part we are having this value in relation number 2, 1 by 2 to 1 by 2 to the power r. Up to this part we are having this value, so we can use this value here. So this is equal to 1 minus 1 by 2 to the power r, and last term is here 1 by 2 to the power r plus 1. This we have writing by relation number 2. Okay, now simplify it. So this is equal to 1 minus, let us take 1 by 2 to the power r common. 2 to the power r is here, this is also 2 to the power r plus 1. So if 2 to the power r is common, this is 1 minus 1 by 2. I hope this is clear. This is 2 to the power r and this is 2. By multiplying we will get 2 to the power r plus 1, and this is equal to 1 minus 1 by 2 to the power r into 1 minus half is half. So this is equal to 1 minus 1 by 2 to the power r plus 1. This is 1 by 2 to the power r into half. So 2 to the power r plus 1 we are getting here. So you see we have come to this right hand side. So this is equal to right hand side. So we are getting here that LHS is equal to RHS. We got the result. Just you write one statement here. So therefore by the principle of mathematical induction, this statement Pn, given statement, this statement Pn is established, means Pn is true for all n. This is true for all n. So this result has been proved here. We got the solution. So very interesting, very simple solution, but question is very important. Okay, so you have understood it very well. We will see some more problems in other videos too. So we will have a good command over this topic. This is very interesting chapter. So we will see some more problems in other videos also. Thank you very much for watching this video. Wish you all the best.